Alright, this is your second lesson in Unit 2, and the note sheet you need to go along with this looks just like this. The beginning part of it has some steps that you're going to use when you solve, and there is some similarities to our last lesson. You do have to distribute when there's parentheses in your equation. You do have to combine like terms. But what you're going to find with this lesson is that you'll see variables on both sides of the equation. Here's your equal sign. So you have the variable x here and you have the variable x here. We're going to start over here with our examples because one of the things that makes these problems differently One of the things that makes these equations different is we do have to end up collecting our variables on one side of the equation and getting our constants on the other side. We need it to kind of look like a two-step in order to finish solving the equation. So please fill in these blanks if you haven't already, and then please fill in this little box. Okay, to make your job of moving variables from side to side and getting constants on the other side, it helps if you move the smaller variable. And I'll show you why in just a second. So as we start our first example, you can see that we have the 6x plus 3 on one side, and if we draw our locker, we have our 2x plus 15 on the other side. And it's just as crowded over here as it is over here. So in order to make it look like a two-step equation, we said we have to get our variables on the other side. First of all, we're not distributing because there's no parentheses, right? We're not combining like terms because there isn't anything alike over here, and there isn't anything alike over here. So what we do to get across this locker is we look at our variables first. If I have a 6x and a 2x, it's actually going to be easier to move the smaller variable. So 2x is currently positive. You're going to subtract it from both sides. And guys, the reason you're doing this is, remember, we want variables on one side. We want all the constant terms or the plain numbers on the other. So 6x minus 2x is 4x. And then when you bring down your plus 3 and you bring down your 15, this should be very familiar to you. This should look just like a two-step equation that we solved before. So remember, always take care of your constant terms. So if it's plus 3, you're subtracting 3. And then at the very end, you're going to get a 12 on this side. So 4x means, remember, 4 times x. And your job is to undo that multiplication. So guys, we're still using inverse operations to solve, just like we had been. From here down, the problem should look very familiar. But at the very beginning, we have to make sure we use this new strategy, which is getting variables on one side, constants on the other. All right, and it really does resemble a lot of what we've done. But at the very beginning, we have to see, oh, I got variables here, I got variables here, so I'm going to use this new strategy. We'll go ahead and check this really quick to make sure it truly does work. 6 times x plus 3 has to equal 2 times x plus 15. 6 times 3 is what we think x is. So we're going to go ahead and plug it in. 6 times 3 is 18, 19, 20, 21. So if I got 21 on this side, I have a little bit more work to do with this type of equation because there's work to do over here as well. 2 times 3 is 6, plus 15 is 21. So it is balanced. If you're using your calculator, you'd have to type two things in. You'd have to type this side in, just the way you see it, and you'd have to type this side in, just the way you see it. So we are confident that x does equal 3. Now we're going to do the next one. The next one's very similar. You have 2x plus 20 on one side. You have 8x minus 4 on the opposite side. If we realize there's no distributing and there's no combining like terms, we're moving on to step 3. Use inverse operations to collect our variables on one side and constants on the other side, keeping in mind it helps to move the smaller variable. So out of the two choices, we have a 2x and we have an 8x. We're going to move our 2x. So what we get, 8x minus 2x, is a positive 6x. Imagine instead if we decided to move our 8x. We'd be subtracting 8x from both sides. 2x minus 8x would leave us with a negative 6x. If you don't like working with negatives because you often make mistakes, then you always want to use this hint, move the smaller variable. That will eliminate the amount of negatives that you have. It doesn't mean you'll never have a negative, but it means it's going to make the problem a little bit easier for you. So look carefully. We have our solution of 20 equal to 6 times x minus 4. Remember, we want to get our variable by itself, so we can't work with a 6 until we take care of our 4. So again, it's subtracted by 4, so we're going to add 4 to both sides, and then at the very end, we're going to divide by our 6. So we should have a solution of x equals 4 this time. Remember, when you check, you're typing your answer into both sides, and you're verifying that this truly has the same value as this over here. 2 times 4 is 8, plus 20 is 28. 8 times 4 is 32. 32 minus 20, or minus 4 is also 28. So it does work out. And again, our new strategy is collecting variables on one side, constants on the other, because you will see with the types of equations you get from here on out that you will end up with variables on both sides, and you will get to some harder problems that do involve the distributing and the combining, but we're not quite there yet. With this example, I picked it because I want you to remember to draw in your invisible 1. In this case, it's a negative 1 that we have with our x. And on the left-hand side of the equation, our variable has a negative 9x. So if we go with our rule of moving the smaller variable to get them on one side and the numbers on the other, it means we're actually going to move our negative 9x. To cancel in negative 9x, remember you're doing the opposite. You're adding 9x. This leaves you with, don't forget to bring down the negative, negative 21. It leaves you with the 35 that we haven't touched. And over here, it leaves you with positive 8x. So from here down, remember, you've got to solve for x. And in 2 steps, we should be able to move our constant term over of the 35, negative 35, and combine them carefully. And then at the very end, we still have our 8 that we're going to divide by. So negative divided by positive is a negative. And we're going to plug that in to check. Being very careful that we're multiplying negatives times negatives, and we're subtracting our negative 7 at the end here, which means we're really adding. Remember, minus negative turns into plus plus. And let's see, on this side, 9 times 7 was 63, right? So 63 minus 21 is 42. So again, if you need to on a check, you should practice this now. Type this in your calculator. Verify that you're getting 42. Type this side in your calculator also, verifying that you do get 42. Finally, we get to a problem that not only has variables on both sides, but you can see it has parentheses on both sides. So what that means is we get a chance to practice not only the variables on both sides trick, but also distributing. Distributing has to come first. Remember, you have to get rid of your parentheses. So 3 times x, 3 times 5, and then over here, negative 2 times x, negative 2 times 10. I'm going to bring my equal sign down inside the locker so I don't lose it. And then I'm going to sit back and think, do I have any combining of like terms that I can do on this side? No. How about this side? No. So that means I move to the next step. I need to collect my variables on the same side so I can get my constants on the other. I want to move the smaller variable. So I have a choice. I can move the 3x or I could move the negative 2x. I'm going to suggest you move the negative 2x because, again, it's smaller. It's going to avoid us having to deal with negatives. So the opposite, or in other words, the inverse operation, if I need to get rid of a negative 2x, remember, is to add 2x. So then I have 5x plus 15 equals, don't forget this, we got a negative 20 when we did the math, so you need to bring down a negative 20. And then remember, from here on down, we move our constant, and we finally divide. So this time it looks like we're getting negative 7. And I think I'm going to have to turn my paper sideways to squeeze in my check because this one took a lot of space. So 3 times our negative 7 plus 5 is supposed to equal negative 2 times our negative 7 plus 10. So this will be 3 times 2, I think negative 6. This will be negative 2 times 3. Yep, it works on both sides. So if you have to, pause the video for a second so you can get your check done. Remember to verify on both sides using your calculator or typing it in exactly as you see it so that you do know that it balances, and that tells us everything we did over here when we were solving is correct. Alright, so for your last example today, we don't have to distribute on the left-hand side, but we do have to distribute over here. We know that there is no actual number written in. That's because we're kind of lazy when it comes to these ones. So draw in your invisible 1. It's really a negative 1, so negative 1 times x is negative 1x. Negative 1 times negative 8 is positive 8. So make sure you are using positive 8 and negative 1x. And then looking at this, we can't combine like terms unless they were on the same side together. So that's why we're moving on to our new strategy, which is moving the smaller variable. So the smaller of the two variables, remember this is positive 1x and this is negative 1x. Right here is where we will use our inverse. To get rid of this negative 1x, we have to add 1x. And on this side, that turns it into 2 x's. And we're allowed to get rid of our 14. I'm going to bring my work over here because I ran out of room with this little decoration. Let's see, we're going to have a 2x on one side and we're going to have a negative 6 on the other. So that means when we divide by 2, x equals negative 3. So guys, take a minute. I think I'm going to copy mine over onto the back to do my check. Make sure that you're comfortable with this topic. See me with questions. And then remember, you're going to cut down the dotted line and you're going to tape it in your notebook so that you have this as an excellent resource.